Hello students, here is the sixth question and the question is a coin tossed three times and we need to determine conditional probability of E by F where E and F are given here. Event E is head on the third toss and F is the event head on first two tosses. So as you know that when a coin tossed three times the sample space S is H, 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 or H, H, T, or H, T, H, or T, H, H, or H, T, T, or T, H, T, or T, T, H, or all coin may shows tail. So these are the possible 8 outcomes when a coin toss three times. So here the number of outcomes in the sample space is equals to what? 8. And here we need to determine probability of E by F. And we know the formula for probability of E by F. We know that probability of E by F is equals to probability of E intersection F divides probability of F. So to determine probability of E by F, we need two probabilities. One is probability of E intersection F and second one is the probability of F. Now see here in this question E is a event and that event is head on the third toss. Therefore, the outcomes of the event E is. So head on the third toss means H is one of the possible outcome because third toss showing head here. And second one is HTH. Here also third coin showing head and THH. So in this outcome also third coin showing head and last one is TTH. So in this outcomes also third coin showing head. So these are the possible outcomes of the event E. And F is the event head on the first two tosses. Therefore, the outcomes of the event F is H is one of the possible outcome because first two coin showing head here. And then HHT is also one of the possible outcome because first two coins showing head here. And then, so these are the only two possibilities of the event F. And now observe here from the event F directly we can identify probability of F here. So probability of F is number of outcomes in the event F 2 divided by total number of outcomes in the sample space 8. So 2 by 8 is the probability of the event F and we need probability of E intersection F. So therefore we need E intersection F and E intersection F means common outcomes in the event E and F. So observe here only one common outcome in E and F that is H. Therefore probability of E intersection F is equals to 1 by A. So therefore required conditional probability of E by F is equals to probability of E intersection F is 1 by 8 divided by probability of F is 2 by 8. So here 8 and 8 get cancelled, hence required probability of E by F is equals to 1 by 2. I hope all of you understood. So let's start the next second question in the sixth question only. So it is a second sub question of the sixth question. Here also we need to identify probability of E by F. Same thing, coin tossed three times where event E is at least two heads and event F is at most two heads. So in this question also coin tossed three times. Therefore sample space of this experiment is H, 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 T, H, T, H, T, H, H, and then H, T, 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 H, T, and then T, T, H, and then T, T, T. So these are the possible 8 outcomes when a coin tossed three times. And now here also we need to identify probability of E by F and we know that probability of E by F is equals to probability of E intersection F divides probability of F. So here the event E is at least two heads. At least two heads means greater than or equal to two heads. Greater than or equal to two heads. Maximum there is a three heads is possible when a coin is tossed three times. Therefore, greater than or equal to two heads means either two heads or three heads. The outcomes which involves with two heads and three heads are the possible outcomes of the event E. Therefore, the outcomes with two heads are HHT, HTH and THH. So H, T, HTH and then THH. These are the only three possible outcomes with two heads. And there is a one more outcome, that is what? Involving with three heads. That is H, H, H. So these are the only four possible outcomes of the event E. And then event F is, event F is, see here, event F is at most two heads, means less than or equal to two heads. Less than or equal to two heads in the sense 0 heads or 1 heads or 2 heads. So therefore here the outcomes with two heads is HHT, HTH and THH. So H, T, H, HH, T and then THH. So these are the three outcomes with two heads, and then outcomes with one head, that is HTT, HTT and then THT and then TTH and then TTH. So these are the three outcomes with one head, and we need to write the zero number of heads, that is what? Tail, tail, tail. So tail, tail, tail. So these are the seven possible outcomes of the event F. So now from the event F, probability of F is equals to, observe here, F has seven outcomes. Therefore probability of F is 7 divided by total number of outcomes 8. And hence we need probability of E intersection F. So therefore E intersection F is equals to common outcomes in the event E and F. See here, event E is at least two heads, means two or three heads, and event F is at most two heads, means 0, 1 and two heads. Therefore common outcomes are the outcomes involving with the two heads. So event E consists two heads and three heads. Event F consists 0 heads, 1 heads and two heads. Therefore common outcomes is outcomes involving with the two number of heads, that is nothing but what? HHT, HTH and THH. HHT, HTH and THH. So these are the only three possible outcomes of the event E intersection F, and we need probability of E intersection F. So now what? Probability of E intersection F, which is equals to, so three outcomes in the E intersection F divided by total number of outcomes is 8. Therefore 3 by 8 be the probability of E intersection F. Now use these two probabilities in required probability. So probability of E intersection F is 3 by 8 divided by probability of F is 7 by 8. So here 8 and 8 get cancelled, hence required probability of E by F is equals to 3 by 7. I hope all of you understood. So now let's start the third sub question of the sixth question. And the third sub question of the sixth question is, here also we need to identify probability of E by F when a coin tossed three times, where event E is at most two tails and event F is at least one tail. So first thing, coin tossed three times. Therefore sample space of this experiment is H, H, H or HHT or HTH or THH or HTT and THT and then TTH and then TTT. So these are the only 8 possibilities of the sample space when a coin tossed three times. And now the event E is, now event E is, see here, event E is at most two tails. At most two tails in the sense less than or equal to two tails. Less than or equal to two tails means either 0 tails or 1 tails or 2 tails. So 0 tails means 3 heads. So 3 heads. So this is one of the possible outcomes of the event E. And then outcomes with one tail. That is what? HHT, HTH and THH. H, H, T, H, TH and THH. So these are the three outcomes with the one tail. And also we need to write the outcomes with two tails. That is what? HTT, THT and TTH. H, T, T, TH, T and TTH. So these are the seven possible outcomes of the event E. And here the event F is, here The event F is at least one tail. At least one tail in the sense greater than or equal to one tail. Greater than or equal to one tail. So greater than or equal to one tail means outcomes involving with one tail, two tail, or maximum three tails. So observe here, the outcomes with one tail is nothing but HHT, HTH and THH. Therefore, outcomes of the event F is H, H, T, HTH and then THH. And also we need to write the outcomes with two tails. That is what? H, T, T, TH, T and T, TH. And then the outcomes with three tails. That is T, T, T. So here we can write the probability of the event F. So probability of event F is equals to, so F has 1, 2, 3, 4, 5, 6, 7. So 7 outcomes divided by total number of outcomes. So 7 by 8 be the probability of event F. And we need E intersection F. Now what? We need E intersection F. E intersection F in the sense common outcomes in the event E and F. So here the common outcomes is HHT is one of the possible outcome which is present in E and F, and then HTH, 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 and then THH, THH, and then HTT. So HTT is exist in both E and F. HTT, and then THT. THT is also present in E and F. THT, and then TTH. TTH is also in E and F. Therefore, it belongs to E intersection F. TTH. So observe here E intersection F as totally 6 outcomes. Therefore, probability of E intersection F is equals to 6 by 8. I hope all of you understood. Now we need what? Probability of E divides F, and we know the formula for probability of E by F. The formula for probability of E by F is equals to probability of E intersection F divides probability of F. So we got probability of E intersection F is 6 by 8 divides probability of F is 7 by 8. So here 8 and 8 get cancelled, hence required probability of E by F is equals to 6 by 7. I hope all of you understood. Let's start the next question. And the next question is determine probability of E by F. So in this question also we need to identify probability of E by F. So and the experiment is 2 coins are tossed. So in this question 2 coins are tossing once. It means the sample space of the experiment is H, H, HT, TH and TT. So these are the only 4 possibilities when 2 coins are tossed once. And in this question, he has given the first question. In that the first question, event E is tail appears on one coin. So therefore, outcomes of the event E, the outcomes involving with one tail. That is what? HT and TH. HT and TH. So these two outcomes has only one tail. And then event F is, observe here, one coin shows head. It means out of 2 coins, we need to write the outcomes in which one coin showing head. So again same thing, HT and TH are the outcomes which has one head. That is what? HT and TH. So these two outcomes has only one head. And now see here, we need probability of E by F, and we know the formula for probability of E by F. We know that probability of E by F is equals to probability of E intersection F divides probability of F. So now by this we can directly write the probability of the event F, which is equals to 2, because F has 2 outcomes and total number of outcomes in the sample space is 4. Therefore 2 by 4 be the probability of event F. And then we need probability of E intersection F. Therefore E intersection F is equals to common outcomes in E and F. So both of these two are exist in event E as well as in F. Therefore the outcomes which are common in E and F are HT and TH. So hence probability of E intersection F is equals to two outcomes are exist in E intersection F divides total number of outcomes is 4. Therefore, required probability of E by F is equals to probability of E intersection F is 2 by 4 divided by probability of F is also 2 by 4. So 2 by 4, 2 by 4 get cancelled. Hence, required probability of E by F is equals to 1. I hope all of you understood this first question. And in this question, he has to given one of the second sub question. And the second sub question, event E is now what? Second question. So in this second question, event E is no tail appears. So we need to write the outcomes in which tail did not appears. It means the outcomes of the event E is. So here among these four, the tail does not exist in the first outcome, that is what? HH. Therefore, only one outcome is possible in the event E, that is HH. And F be the event. No head appears. So means both the coin shows tail. So the outcome which both tail is TT. So T, T. So in this only one outcome, no head is appearing. Therefore, outcome of the event F is TT. Here also we need probability of E by F, and we know that probability of E by F is equals to probability of E intersection F divides probability of F. Therefore, we need probability of E intersection F and probability of F. So, directly we can write probability of F is equals to one outcome divided by total number of outcomes 4. So, 1 by 4 be the probability of F, and then we need probability of E intersection F. Therefore, E intersection F is equals to, see here, E has only one outcome, that is HH. F has also only one outcome, that is TT. It means there is no common elements between E and F. Hence, E intersection F will be null set. So it means probability of E intersection F is equals to number of elements in the E intersection F, which is equals to 0. Hence its probability is 0, because 0 by anything is 0. So probability of E intersection F is 0 and probability of F is 1 by 4. Therefore, required probability of E by F is equals to probability of E intersection F is 0 divided by probability of F is 1 by 4. Hence, 0 by anything is 0. Hence, required probability of E by F is equals to 0. I hope all of you understood this seventh question. Let's start the next question. And the next question is, determine probability of E by F. So in this question also we need to identify probability of E by F, but the experiment is a die thrown 3 times. So when a die thrown 1 time, number of outcomes is 6. When a die thrown 2 times, number of outcomes is 6 square, which is equals to 36. And when a die thrown 3 times, number of outcomes is 6 cube. So 6 cube is equals to 216. Therefore, the number of outcomes in this sample space of the experiment is 216. 216 is the number of possible outcomes of this experiment. And here the event E is. Event E is. So observe here, event E is 4 appears on the third task. It means out of 3 dice, the third die must shows the number 4. It means first 2 die shows any number, but the condition is on only third die. That third die must shows the number 4. It means the possible outcomes of the event E is. So observe here, 1, 1, 4 be the first outcome or possible outcome of the event E, because in this outcome the third die showing 4, or 1, 2, 4 is also one of the possible outcome, or 1, 3, 4 and so on. So ಇಲ್ಲಿ ತನಕ ಬರಿಬಹುದು 1, 6, 4, and then next possibility is 2, 1, 4 and then 2, 2, 4 ಇಲ್ಲಿ ತನಕ ಬರಿಬಹುದು 2, 6, 4 and then 3, 1, 4 and then 3, 2, 4 and so on. So 3, 6, 4 and then 4, 1, 4 and 4, 2, 4 and so on. So 4, 6, 4 and then 5, 1, 4, 5, 2, 4 and so on. So 5, 6, 4 and lastly 6, 1, 4, 6 to 4, 6 to 4, and so on, so 6, 6, 4. So these are the possibilities of the event E. And F is the event. Observe here, event F is 6 and 5 appears respectively on the first two tasks. It means first die shows number 6 and second die shows number 5. There is a condition on only first two tasks. First die must shows the number 6 and second die shows the number 5. But third die may shows any number. Any number means either 1, 2, 3, 4, 5, 6. Among these 6, that third die may shows any number. So therefore, possible outcomes of the event F is, possible outcomes of the event F is, so observe here, first die showing number 6, second die showing number 5. So third die may shows the number 1, or number 2, or number 3, or number 4, or number 5, or number 6. So these are the only 6 possible outcomes of the event F. I hope all of you understood. Now in this question also we need what? Probability of E by F, and we know that probability of E by F is equals to probability of E intersection F divides probability of F. So observe here, probability of F. So F has 6 possible outcomes. Therefore, probability of the event F is equals to 6 divided by total number of outcomes in the sample space, that is 216. So therefore, 6 divided by 216 is the probability of the event F. And we need probability of E intersection F. E intersection F means common outcomes in event E and F. So observe here, first event E as the outcomes whose third die showing number 4. It means the common outcomes in E and F is nothing but the outcomes in which their third die showing number 4. Therefore, there is only one possible outcome which is present in E and F, that is what? 6, 5, 4. 6, 5, 4. So this is the only one outcome which exists in E and F event. Therefore, probability of the event E intersection F, probability of event E intersection F should be equal to 1 divided by 216. Hence, probability of E by F is equals to probability of E intersection F is 1 divided by 216 divided by probability of F is 6 divided by 216. Here 216 get cancelled, remaining 1 by 6 is the required probability of E by F. Hope all of you understood this question. Let's start the next question. And the next question is, determine probability of E by F. In this question also we need to identify probability of E by F. And the question is, if mother, father and son line up at random for a family picture. So first we need to write the sample space. See here, in this, the sample space is nothing but the possibilities of lining of mother, father and son in their position. So it means, see here, let's say M stands for mother, M stands for mother, F stands for father, and S stands for son. So see here, there is a possibility that if suppose, now observe here, this the writing the sample space of this experiment is related with the permutation. Permutation means arranging. We are arranging mother, father and son on a line. It means we are arranging 3 members. It means 3 vacant places. So first vacant place can be filled up with 3 different ways. It means either mother can stay here, or father can stay here, or son can stay here. So if one person stayed in the first position, there exist 2 possibilities for the second position, and similarly one way to fill the first position. Therefore, the total possible arrangements for mother, father and son for a line is 3 into 2 into 1, which is equals to 6. It means definitely the sample space of this consisting 6 possible outcomes, and which are those? See here, suppose mother stays at the first position. So it means second position may be father or son. So it means MFS and MSF is mother stands at the first position. These two are the possibilities when mother stands at the first position. Or there is a possibility that father may stands at the first position. So if father stands at the first position, the remaining two possibilities ಏನೇನು ಬರ್ಬೋದು M S R S M. So these are the two possibilities when father stands at the first position. And there is a possibility that son may also stands at the first position. So if sun stands at the first position, remaining two positions may be FM or MF. So these are the possible outcomes of this sample space. And now we need to write the event E and F. So here the event E is. So observe here, event E is sun on one hand means it may be on first hand or on last hand. So it means sun on the first hand means MFS. So in MFS, sun is at the last hand, and FMS. So in this outcome, sun is at the last hand, or SFM and SMF. So in these two outcomes, sun is at the first hand. So SFM and SMF. So these are the only possibilities of the event E. And then we need to write the outcomes of the event F. Outcomes of event F. So event F is father in middle. So we need to write the outcomes in which father is at the middle position. See here. So in MFS, father is at the middle phase. So MFS, and then SFM. So in this outcome also father is at the middle position. These are the only two possibilities in which father is at the middle position. So in this question also we need what? Probability of E by F, and we know that probability of E by F is equals to probability of E intersection F divides probability of F. So directly we can write the probability of event F here. So because F has two outcomes, 2 divided by total number of outcomes in the sample space is 6. Therefore 2 by 6. And we need E intersection F. So E intersection F is equals to common outcomes in event E and F. MFS is common in both MFS, and SFM is also common in both. So SFM. So there exist only two outcomes in event E intersection F. Therefore probability of E intersection F is equals to 2 divided by 6. I hope all of you understood. So now substitute these two probabilities in probability of E by F. So probability of E by F is equals to probability of E intersection F is 2 by 6 divided by probability of F is 2 by 6. Here 2 by 6 get cancelled. So remaining 1. So probability of E by F is equals to 1 is the answer. Hope all of you understood.